Hello and welcome to this new series where we are going to learn about how to design neural networks. And I'm going to closely follow the book Neural Network Design, which is available at this link. I've also put it here in the bottom of the page. The book is by Martin, Howard, Mark, and Orlando. So, this is an amazing book. Um, and I think it's one of a kind book which gives you an insight into how to think about the architecture of neural networks. And in this video, we'll try and learn the basic concepts behind simple neural networks, and hopefully that uh, knowledge of understanding how the basic neural networks function, how they work, will help eventually to create custom architectures for your project needs, and also understand the state of the art uh, architectures that are available, which are much more complex. Hopefully, these would be sort of the tiny building blocks in this series that will help you uh, uh, at least understand or read into the architectures that are much more complex. So, in this series, what I'm going to do is I will be explaining the concept, and for explaining the concepts, I'll simply draw figures here and maybe use only the math that is required to understand that particular concept. We are not going to go into any derivations and no coding, just pure concepts, and hopefully that will uh, help you learn how to think about uh, putting things together in building a neural network architecture that would be customized for the prediction model that you are trying to create, or customized for the output that you are trying to get. Right. So with that, let's first think about what is a neural network. And a neural network, in very simple terms, uh, is uh, is something we can start thinking of it as a box, and this box has, let's say this is a box, so this would be some sort of model, and we give this input, one input or multiple inputs, and that gets us an output or a prediction. And what is inside of this box is the focus of this series. So inside of this box, when we talk about neural networks, there is some level of math in it, and that is can be as simple as the following. We have some weight associated with each input. So by weight I mean importance, right? So we give some importance to each input. So this is importance. So we give some importance to each input, and to make that happen, we multiply the weight or the importance of each input with the input itself. Okay, so this is the first thing we do, and then to this we add something called as a threshold, or we call this as a bias. And right now you may not get the entirety of what I'm talking, but eventually you will. So this bias just helps this neural network, the box, adapt and be more flexible to get you a correct prediction. Okay, so this thing that we have written above is written in a notation form where we specify the W weight by W. We are going to specify the input by the letter P, and we are going to use the letter B to specify the bias. And what this is, what we have here, WP plus B, this is what we are going to call as the net input. So this is the net input, and we are going to denote it by the letter N. So what we have then is N is equal to WP plus P. So that's the sort of math at the very simple level that's going on. And this is not the output, this is not the actual output, this is the input. Input to what? Input to a something called as a transfer function, or also called as a activation function. And what this is essentially we take that value of N and pass it in to a function, and whatever output comes out, we are going to denote that by the letter A. Now what, if you are not familiar with this notation, what I mean is, let's say we have a value of x is equal to 1, and then we have some function of this x, which is x square plus 1, right? So now if we want to use this value of x in this function f of x, what we are going to do is say, well, I'm going to replace that x by 1, then replace the x by 1 here, and so what I get eventually is 1 plus 1, and that is 2, right? So that's what this is. And in case of neural networks, the function may not be as simple as this. They could be, but one of the most common functions that you'll see is denoted by, because n is going to be the input, rather than saying x, I'm going to use the letter n. N is equal to 1 divided by 1 plus e to the power minus n, and this is called as the sigmoid function. It's completely okay if you do not understand this right now, because we are going to look into this later on in the series. For now, we just need to know that whatever net input is calculated here is passed into a function that outputs a value which we are going to denote by the letter A, and this is going to be our prediction. Okay, so that's the prediction. This is that's all there is. So that's how we predict in a very simple uh, uh, simple way to think about a neural network could be this. And it's not a perfect explanation, but this is a, I think, is a good starting point on which we can now build up in subsequent videos. So the input is going to be the letter P, output is going to be the letter A, and then inside of this are going to be the weight. So this is what I want you to remember, which is the what is it that we are trying to do. We are trying to multiply each input by its importance or weight, and then adding a bias to that, and that gets us the net input. And then we take that net input and put it in some sort of a transfer function uh, to get us the final predictions. Right, so that was it for this video, and again, I'm very thankful to the authors of the book Neural Network Design for making this open source. And you can also get this book on that website, and it's available for download. As you can see, there's a free copy of the ebook available that you can download. So I hope that this helps you take your step in the direction of learning today's modern neural network architectures, where this fundamental knowledge of what happens at the tiny level, at the brick level, is also important to understand. Okay, if you have any questions, comments, or suggestions, please feel free to share them in the comment section below. I hope to see you all in the next video, and if you have any specific requests, I'll be happy to look into those as well. So thank you, and let's get going into designing neural networks.